Hello. So we are back, yeah? Wednesday morning, around half 10, yeah? Beautiful weather outside. So, like how I said a few videos ago, yeah? I'm trying to do like jobs, like different, like new jobs, which I don't know nothing about them, and apply the electronics knowledge, yeah? So today we have a nice job. I will show you. No, I can't fit it on the desk, but I will show you, yeah? You know. How about this? Hopefully you can see. So we have a big Bluetooth speaker. It's a Sony one, and the model is GTK-XB7. Yeah. So that's what we have to fix. The problem with this one is that, yeah, but I haven't checked anything. I open the screws. It's getting open by the top. Yeah, this one. And we have here the digital part and I don't know, the buttons and things. And inside we have the boards. So I open the screws and I will take out. Yeah, I checked before it's dead. So, but I haven't checked anything else. So I'll take this out to see exactly what's going on here. Okay, so this is out. This is everything electronic here. We have the speakers. I think we have a screen. And yeah, that's all. I think that the display should work without the speakers. Yeah, that's what we have to fix. So what happened exactly? I will plug this ribbon cable here. Okay. Okay, let me plug a power cable. Power cable plugged. So now, if I press the power button, I should have some lights and some things. But it's no light, it's nothing, it's just dead. Okay. So what I will do next, let me get this ribbon cable out. Probably the first things what I will check will be the power supply, obviously. And normal, yeah? So what we can expect to be here? We expect to have a power supply, to have an audio amplifier, and to have the digital part and Bluetooth thing, yeah, because it's a Bluetooth speaker. Okay. So let me grab the multimeter. Let me power up the microscope. Okay. So what do we have here? We have the power supply. Yeah. I wish to have like a close-up camera. Power supply. We have this connection, and you know the good part is the voltages are written on the board. Yeah. So let's see, what do we have there? So what do we have there? We have the what voltage? We have only one voltage, 36 volts. Yeah, so we have to check if we have that voltage. Yeah, so actually we have no signal, we have nothing, we have just 36 volts, which probably must be there all the time. I don't know what's the pin number 1. Well, let's check for voltage, yeah? Multimeter. How can I fix this? Yeah, like that. Ground. Let's say plus, yeah? And we have 34 volts, which I think is fine, yeah? So 34. So the power supply is good. So we don't have a power supply problem. Okay, that's bad. Okay, probably what I will check next, yeah, it will be if we have any voltage on the digital part, because it's not coming on. So it's not coming on because the power supply is faulty. No, it's not coming on because I pressed the power button and nothing happened. So two things: the digital part is burned, or the digital part doesn't have voltage, or only these two things, yeah? Only these two. So let's try and check the power buttons. I will check the power button for voltage. That's the first thing what I will check. Because I have no idea where it's plus and minus on the digital part, because obviously we have no voltage, yeah? But I know for sure I should have voltage on the power button. True? Multimeter. Power button. So the power button sign is here. And we have nothing. I can't see. I'm sorry. So we have the sign on the board. You know, the switch sign here. And the switch sign here. So here is the switch, because on the other side is clicking, so I should have voltage here. So that's the power button, and it's no voltage. Okay, what I will do next, I will try to identify the power supply, and I will concentrate my attention on the big caps, like this one. So we have here a tiny antenna, so I suppose this is a Bluetooth module. And this is a capacitor. And on the capacitor we have nothing, 0 volts. Okay. Next one, we have here like a carbon resistor, so probably that's like a small one, a tiny one, 0 point something ohms. We have two ceramic big capacitors, so I suppose there should be a power rail, yeah? So we use ground, and I will check next for voltage. And it's no voltage. Okay, so I believe our problem is not from here. I believe our problem is from here, yeah? So let me unplug the cable. Okay, let me take this out. And let's move on the second part. Here we have probably the processor, and probably this is a memory, I don't know. We have some, you see these big coils, this coil, this is a power supply. Here we have a transistor. Can be a regulator, yeah. Here we have a BIOS chip. So this is our processor. So let's see what's going on there. Here we have a heatsink and we have some coils. So I believe this is a power amplifier class D. I think class D is the newest one and is like, you know, it's the new amplifiers with MOSFETs and things, and actually they are very efficient. And here we have a relay which is supposed to connect the speakers or connect the audio amplifier. Yeah, connect the powerful audio amplifier, I think. Or maybe not. I don't know, but I don't care. My issue is I don't have voltage on the on that board with the power button. Yeah. So I'll connect the cable again. And the problem is I don't know nothing about this. Okay. So I have no idea what's going on here. So I'll check some voltage on coils. Yeah. You have no schematics, so if you have no schematics, everything is random on the board. But you can separate the things, like probably this is like a power supply area. Yeah. Here is the processor. 1 second. Okay, sorry for that. Yeah. So yeah, like how I said, the power area, the digital one, the audio amplifier. So let's do some checkings. Yeah. Ground. Now let's check on these coils to see what we have here. Yeah. I'll check on caps, it's more easy. So here we have, sorry, this should be voltage. Okay, voltage. So here we have 12.2. Okay, so this is a power supply and it's a working one. Here I can check straight on coil. Here we have nothing. Let me check on the capacitor. It's not necessary to all the power supplies to be on. Yeah, maybe they are coming on when you press the power button. So we don't know. We can't say like if there's no voltage, the power supply is faulty. Okay, here we have another coil. Let's see on this coil. 5.2 volts. Okay. One more on the BIOS chip. On the BIOS chip, the pin number 8. And we have 3.3, really? No, we have nothing. What's 3.3? No, 0. Let me check with the other multimeter. I don't really trust that one. No, it's 0. No, 0 volts. So we don't have voltage there. Okay. The closest regulator is this one. Let's check this one. Nothing. 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 So we have no voltage even on that regulator. Okay. And this one is a 5 volts power supply, yeah? Yeah. Okay. Here we have a capacitor. We do have 5.2 volts. What do we have here? These connectors, speakers, and parity gain. Okay. Okay, we have a USB port, so can be the 5 volts power supply to supply power to the USB. Yeah, can be. Okay. Here we have another small chip, so I suppose it's another regulator, and on the output we have... Why is changing to ohms? I can't believe. So here we have 0, we have nothing, so this is not working, whatever it is, yeah? Here we have a ARM chip, so probably this is a microcontroller, which we have no voltage on the crystal, so probably is that the chip has no voltage. Okay. So this power supply is good. This is a 5 volts one. That's good. So it's hard to spot the problem. From here we have a small chip, so probably this is another power supply, which is 0. So we can't really know what can be the problem here. Yeah. But I would get concentrated, yeah, on these power supplies. This is nothing hot. It's okay. You know what I'll try to do more? I'll try to check for short on the BIOS chip, which probably is the 3.3 volts power rail diode. So let's check. Pin number 8 and pin number 4, and it's not short. It's not short. Okay, that's good. It's good to know, you know. Now what I will do next, yeah? What I will do next, I will try and find, yeah, so here we have the processor, okay? Here we have the BIOS. What I will try to do, I will use the continuity, yeah, and I'll try to find the processor and BIOS power supply, yeah. And for that one, I will stick one probe here, and no, here, sorry, here pin number 8, which is probably plus, okay, and I will try with the beeping. Okay, it's going here. So here we have some carbon resistors. So probably this is the main. You can see the track. So probably this is the main 3.3 volts power rail. It's beeping here, and it's beeping here. So I know for sure this transistor is meant to supply a regulated 3.3 volts. I know 3.3 because the BIOS chip is a 3.3 volts one, yeah? So if this is a regulator, which this is the output of the regulator, let me check what regulator is that one, if we can check. No, it's 1117A, yeah? Which I don't really know what it's doing, but we can check online, you know. 1117A. The data sheet, yeah? Okay. Yes, and I found something. 1 second, let me switch. Regulator, okay. Well, let's see what it's doing. It's a voltage regulator. What I need the pins configuration, so I know which is our input, yeah? So we have this vein. Okay, so we are on the wrong direction. So this is V in, this is V out. Okay, so I believe this one is there. So from 3.3 is going here and is coming out with different voltage, probably 1 point something for different, I don't know. Or what I'm doing wrong here. Because that's the input of the regulator, it's not the output. So what I'm doing here. One more time, yeah? Let's check one more time. So from the pin number 8, yeah, it's not coming here, it's coming here. Okay, so this is not our regulator, this is the input of this regulator, yeah? So we should try and find out different power supply, yeah? So it's not this one. What about this one, the dead one? It is? That's the one? No, it's not this one. Okay, what about this one? Can be this one? No, it's not this one. So where is going my power rail? Here, here, maybe here? No, no. So it's not coming here. Okay, so probably it's not here. Probably it's not here. Okay, it's not here. Here? No, it's not here. So where is my 3.3 volts power supply? What about here? Yeah. So here we have 0. No, we don't have 0. Here we have voltage. Yeah, we have a capacitor which is getting charged. Okay, so it's not this one. So which one it is? Which one is the 3.3 volts power supply? And this clearly is the input. Yeah, let's check this. Let's get concentrated. Let's see where the output of this one is going. Yeah. Okay, doesn't mean that's the ground. Yeah, it is the ground. Let's see where this is going. This is going to the chip. So the chip need two voltages. One from here, the 3.3, yeah, which is coming on the chip, yeah, and one from here, which is going somewhere here. Okay, but that doesn't help me, you know. I still need to find my 3.3 volts power supply. Okay, so I know it's coming here. You know, I can see this track and I was thinking where it's going. So probably it's going here, this one, yeah? And from here it's coming to this transistor. And probably this transistor, yeah. So I believe my power supply is this one, which is not working. So this is the 3.3 volts one, this one. Okay, let me plug again the cable and let's check again to see if we have input. So the power is plugged. Let's check voltage. Volts. Let's try to check again. and my screen goes off. And now it's ohms again. Volts. Okay. So this power supply is dead, and I believe this is meant to be on all the time. And we have this coil, and we have this switching thing. You can see the coil on a serial mode with this switching thing, yeah? And probably this is the input, yeah, this one. And on the input we have 0, and we have two resistors. Resistors which are good, and these two resistors is coming from here. So this power supply is on serial mode with this power supply. So in order to have this working, I have to have this working. Yeah, this is another power supply. Remember, we checked and was dead, and I said, you know what, it's not necessary to be on. So this power supply is dead. This power supply is driven by this chip. Yeah, this chip input is this here, and on the input we have 34 volts. Yeah, you can see on this pin 34 volts. I don't know how much voltage will be on the output, but we have a diode here. Possible to be a Zener diode and possible to have a short here. So my attention is now on this chip. Yeah, so let's take the power out, let's switch on diode mode, and let's check that diode. And this diode is it's 0. Okay, so I think that is short. Continuity 1.8 ohms, 3 ohms, 3 ohms. So I believe something is wrong here. Sorry, you can't see, because we have like, no, it's 0.5 ohms, 0.5 ohms here. So this is the output of this power supply. Yeah, this is the coil. After the coil we have the capacitor. Yeah, we spoke about the power supplies, the switching ones. So I don't know if this diode is burned. Yeah, can be something else, can be like different things burned, but it's most likely this diode which is on the output. Most likely it's a Zener diode. So I'll remove that diode and I'll check again. Yeah, let me grab a nozzle, 1 second, the small one. So let's remove the diode and check for short. Yeah, that's all what I want to do. More air. Okay, let's leave the diode and check the diode with the multimeter. And the diode is good? Really? Okay, the diode is good and the short is still here. Okay, that's bad. That's bad enough. So it's not a diode. Let me solder back the diode. Now, what I will do now, the soldering style, you know, the brute force, the savage way. I'll come with a lot of amps from the power supply, and I'll try to find out what is getting hot here. Yeah, so I'll use petrol, you know, Zippo petrol. I see many comments, what petrol, car petrol? No, it's Zippo, you know, Zippo, you know, for lighter. I'll just use Zippo petrol. Yeah, and I want to see what is getting hot here. Power supply, I will put the power supply on the low voltage because I don't know what voltage has that power rail. Yeah, so we don't know. Maybe, but should be minimal, like 3 volts. Yeah, 3 volts, around 2 amps. Now let's see. Ground. And what is getting hot here? Huh? Okay, let me pay attention of this chip. Maybe this chip is dead. One more time. It's taking 2 amps and the voltage is 0.6. So sometimes something is getting mad hot, but I can't see nothing here. I can't see. The thing is, the capacitor? I don't think it's the capacitor. You think it's the capacitor? Can be? Let's put some pressure on the capacitor. No, probably it's not the capacitor, yeah? But something else is getting hot. Well, obviously we don't know what, because this power relay is long, you know. This is probably going on different things, different chips. Let me try, yeah, and try to find out by heat. See what is getting hot on the, you know, on the older board, not only here close to the power supply, because I think this fault is somewhere on the board but not near. Okay, so let me stick the ground somewhere on the case, because the case is ground. That's plus 2 amps. Okay. Okay, let's go up. Let's go 2.3 amps. Yeah, let's say 3 amps. With 3 amps, something is burning. Something should be burning hot. Okay, okay. The coil is warm, so very possible the short should be on the other side, not on the output of the power supply, but on the output of the before the coil, yeah, on the switching part. You know what I mean? So you have the switching, the driver, yeah, MOSFETs. You have the coil and the output. I think the short is on this side with the switching devices, yeah. I think, but I can't say for sure. Let's use more amps, yeah. 3 amps. Let's check again. Yeah, 4 amps. 4 amps. Yeah. Yes. Oh, okay. Let me switch the amps down. Let's have a look together, because something is getting hot there, but I don't know what. So like how I said, yeah, that's the schematic of the power supply. So the things that this from here is going out to my board. So this is going through the coil to the driver, you know, the MOSFET driver. This is a chip, but inside there are some MOSFETs, they are switching, yeah? So that's my power supply. So the direction of the power is coming from this side, here, and it's coming on this side, yeah? It's like that. It will be to draw like a arrow, yeah? So I checked on the output, yeah, going, but it's not. It's here on the somewhere here. Something is getting hot. Let me use petrol, yeah. Let me use more petrol here somewhere. Now let's check again with the power supply. And let's see what is getting hot there. I can see here some movement. You can't see when I put the okay, you can't see, okay. On, off. On, off. Choose more amps. On, off. Okay, here is weird on this cap. What do you think? On, off. On, off. On, 3.2 amps. 3 amps now. And I can see here some movement, but I don't know what was here, because here it's warm, hot. But I don't know what's there is short. That cap, look on that cap, yeah? Look on that cap, yeah? This black one. So what do you think? You know, a cap is not meant to do like that, you know? A cap is not driving the electricity through, you know, on DC. So let me remove that cap. Okay, that's normal. No, 1 second, that's normal. Okay, that's the diode. Or it's not normal. It's a diode or a capacitor? Now I'm confused. We have one more here from the ground. Can be diode, can be capacitor. Can be a diode. So we have the output of this chip, which is coming to the coil and is coming to this. This is a diode. This is not a capacitor. I was thinking it's a SMD capacitor, but I think it's a diode. Let's check online. SS34B. Yeah. 1 second. SS34B. 34B. Yeah. So we found. What did I click? What did we found? SS. It's not here. SS. It's not here. Or here? Yeah. SS34B. Surface mount Schottky barrier rectifier. So we know it's a diode. It's a Schottky diode, yeah? Schottky? Something like that, yeah? So let's remove the diode, check the diode, check for short. Okay, so this diode is meant to be here to cut down the flyback current. You know, it's a flyback because we have a coil. You know what I mean, yeah? And here on the other side is the ground. I need more air. So this is a very important lesson. It's about how you step by step find a fault on something which you have no idea what it is, yeah? On something which you don't have a schematic, yeah? And you just apply pure electronics knowledge, yeah? Okay? So let's check this diode. Ohms. And here the diode is shorted, it's 1 ohm. You can see there on the multimeter. Let's find another diode. What do we need? We need a fast switching diode. Fast switching diode. Fast switching one. What about plasma board? We can find. Let's see. Yeah. Yeah, are a lot. I think all are fast switching diodes. Yeah. So I will use. I will use any diodes. What do you mean? These are all fast switching diodes. You can't see. Sorry. Here. So I will take any diode. Okay, the diode is out. Let's solder the diode back. PJ2029. Probably it's a Scotchy diode. But you know what? We can check PJ2029. Yeah, we can check. PJ 2029 2029. Yeah, same thing. Scotchy rectifier, yeah. Scotchy, sorry. Let's solder that diode. I can't believe. 1 second. Okay, let's solder the diode. Well, let's use some flux. 1 second. Just to be sure it's soldered. Actually, the board is used, yeah, by like a heatsink, yeah. So the diode is getting cooled down. By the board. So it's very important, like the things to be soldered properly. This is a flux, nothing else. And now we are sure it's solder in place, yeah? Let's just wait to cool down and we can plug the power and we can test it. Yeah, we can find more damage, like it's not only this shorted, it's also the chip is shorted. Yeah. So we can find more damage. I'm not sure this is finished. I can use some heatsink to cool down the thing. Yeah, let's cool down. It's just a thermal pad, you know thermal pad? It's a composite thermal pad. Let's plug the cable, the power cable. And let's check some voltages, yeah? Volts. Now let's check the output, yeah? And here we have 2.4 volts. Okay, that's a little bit too low. Only 2.3. Okay, one more time. That diode is fine, it's not getting hot. But it's hard to believe here should be 2.3 volts. So what about the other power supply? What do we have on the output of this one? Nothing. Or which is the output? 2.3 volts. You know, I'm not okay with this. The diode is fine, it's not getting hot. Let me check the BIOS chip voltage. Same 0. Okay. So like how I told you, this is not yet solved. So on the input you have 34 volts. On the output 2.3. We have here a 2.2 ohms resistor. I'm not happy. I'm not happy at all. So something is wrong here. Why only 2.3 volts? And the input of this one second, let me check. So we have this transistor. No, how I said here is 2.3 and it's coming on this one, and the output of this one is nothing, 0. So this is not even switching with 2.3. This one. Okay, here we have a power supply which is working. Yeah, this is the 12 volts one. You know what I will do? I'll switch the diodes just to be sure it's not a diode problem, yeah? So I will unplug. Yeah, that's the risk when you are not using same parts. Well, I don't think it's the diode, you know. If it was like a diode to be open too long, the diode will get hot. So I don't think we have a diode problem, but I will switch the diode anyway. Now this is the same diode. Okay, so I'll put this diode here. Okay, the diode is soldered. What about this? This is a working power supply, so you can see if it's working with my diode. Come on, just stay there. Okay, that diode is soldered in place. Well, let's cool down. You know, that's what I hate. When something is working, so it's not burned, it's not working fine, it's just working somewhere on the half, like this power supply, 2.3 volts, which is not normal at all. Okay, let's plug the cable and check that power supply, the 12 volts one. So let's see my diode is working. No, it's not working, it's 3.4 volts. Oh, that's sick. What about the other one? This one? Even this one is not working. 44 volts. And on the output we have nothing. How this is possible? And this here 3.4 volts. Okay. So I will get my words back. You cannot replace that diode with any diode. Let's check for short. On this one, which is not working, and I don't understand why. So this diode is good. It's shorted. Yeah, it is shorted. So I think the diode died. That diode died. Okay. What about this one? Here it's only 3.4 volts. It's supposed to be 12. Okay, so yeah, it's important. The diode is important. Probably the switching the switching speed is important on the diodes. So let's find another diode, a proper one. You know what? I have some TV diode here. I think that will be fine. A TV diode. What do you think about that? Not anymore. It's not here. Yeah, don't worry. I'll find another one. I should find on laptops. Laptop boards. Or a power supply board. Oh yeah. Oh yeah, a TV board. Yeah, uh, okay, let's try to get a diode from a TV board. That's strange. That's proper strange. Hmm. Okay. Okay, let's use another one. So I got long way, just finding this fault, and now I get stuck for a diode. I can't believe. Because obviously we don't have that diode, and now we don't have time to order the diode, because this should be fixed today. Okay, this is just a random diode, another Schottky diode, random one. One second. Okay, the microphone was off, I can't believe. So we need a proper diode here. It's not working with any diode. Let's study this diode, the burned one. Yeah. So what do we know? No. Hmm. Where I can find something like that? You know what? Let's use a TV one. It's too big. Big one, normal one. 5 amps diode, and I don't need 5 amps. Okay, that's not good. Now I get worried, you know. Where can I find a diode? If I'm stuck here because I don't have a diode. Power supplies board. Power supplies. Okay, let me play. Let me play and use this diode, yeah? This is a big one. Okay, give me 1 second because I'm alone here. Yes? Okay, with what problem? Да. Okay. Let's solder the diode. Yeah, of course I can't solder because my solder iron it's only like 25 watts. I'll show you after. Let's test first. Power cable. Minus, plus. Okay. Bubble on the input. I was checking with this one. Okay. Can't believe. Same thing, 3.4 volts. It's not working. It's not working. It's not supposed to be 3.4. So we need to find a proper fast switching diodes, otherwise it's waste of time. Yeah? Okay? So we need proper fast switching diodes. Or something is wrong. But I don't think it's nothing wrong here. I think the problem is the diodes. To get the diodes from where? Yeah, I found some diodes. Let me change the nozzle. Okay, these are from power supplies. They should work. Okay. Let me check. Ground. Let me cool down the diode. Okay. Okay, that's the life. So let's see this one. It's working. $12.6. So yeah, it's working. Yeah. So let's replace the second one, which I know is shorted. Yeah. Yeah, so the diode is important. What diode do you use? What did I use? I used these kind of diodes, which are big, probably better. But I learned my lesson, yeah? I learned my lesson. Let's use some solder wire. The spares are very important, yeah? So you know what I mean. To have all the times board so you can take things like here, like diode. This is a big diode. Yeah, so the switching speed is important. I don't know how I'll solder this way. I can, or maybe not. Wow, it's hot. How can I do it? I think I'll do it with the solder iron. Or maybe not. Okay. Okay, let's cool down and let's check after, yeah? Anyway, it's an expensive Bluetooth speaker. So I think it's worth, the time what we spend on this. But a simple thing, like a shorter diode change on so long thing. Yeah, let's see. On. Volts. So what do we have here? Here we have 12. Here we have nothing. Okay. Input 34. Output nothing. That's not good. That's not good at all. Why we have nothing? Still shorter. It's not short. 97 ohms. My diode? Really? No, my diode is good. So what's the catch? The circuit has only 18 ohms. The output so how this is possible? The coil 22 ohms. The coil on the other side 5 ohms. Four ohms. Something is wrong here. Why now is short? The diode is not connected. Three point four. 3.3, 3.2. Yeah, let's get the power supply. Let's get the power supply. And that resistor is getting hot. 2.2 ohms. Let me get out everything, yeah? But why? Why this happened to me? Hmm? What do you think? Why? So again, yeah? Here is short, 2.8 ohms. Here obviously is ground, yeah? What's here? I don't know, here is something else. But this resistor, if I come with amps, is getting hot. So I believe my chip is gone. I think my chip is gone. That's bad. That's proper bad. Let's come with the power supply again. Yeah. 1.4 amps. That resistor is smoking. Okay. So that's gone. Let me see if those chips are the same. I think are the same. Let me check this one. This one is 6 or P3490. P3490. P3490, which is nothing. Okay, 1 second. Hmm. Okay. So what power supply is supposed to be there? Hmm? So the output cap 10 volts. That means the power supply should be 5. Let me check those chips. Oh, this is something else. Hmm? Okay. I don't even know what board is this. There's some TV board. TV, no, probably CCTV board. Yeah. Okay. We are good. We will do try some things. Yeah, let's use 5 volts on output. And let's try to find out what power supplies this. Yeah. Less amps. 800 milliamps. And the current is 2.7 volts. It's dropping down. So I think we have a short. But yeah, the short is there. Yeah, I know. The short is on that resistor. No, actually. Oh yeah. Let me get out the chip. 1 second. Give me 1 second. I can't believe I'm speaking with the microphone off. Okay, so what we did and what we have right now, yeah? Yeah, this is already too long. So what happened exactly now, yeah? I come with the 5 volts here. So this is a 5 volts power supply. I'm happy with that because I can use something else to supply power here, yeah? So I come with 5 volts here. We have on the ammeter on the screen 300 milliamps, yeah? And it's going down to 90. But the problem is if I check the power supply, the second one, yeah? The second one which must be 3.3, this one. On the output we have 3.3. You can see that 3.3. But the voltage on the bias is going down because this is also switching. So this transistor is a switch. We have 0 here, and we have here we have 3.3, yeah? So if I'll keep there, this is the BIOS power rail and the processor power rail. So I'll take the power from here. When I put the power, it's going down. Now we have 3.3 and it's going down to 0. And that can be normal, yeah? Can be kind of normal, yeah? Let me connect the panel and see if it's working, because if we don't have a working thing, let me see if it's working. So what do I need? I need this, yeah? Let me connect the connector. Let me connect the panel. The panel is connected, yeah? Let's only use 3.3 volts. Sorry, 5 volts. 5 volts. We do have power on the power button. Here we have green light and off. Let's press the power button. Green light and off. Let's press the power button and it's coming on. Yeah? So now it's on, but obviously we don't have this cable connected. Yeah? So what I will do, I'll modify the toy because it's working fine. Yeah? So my chip is burned. I took out the chip if you checked. One second. Yeah, so I removed that chip and the diode here was, yeah? So I removed that one. It's gone. What I will use, I need a 5 volts regulator. 5 volts regulator. I need from somewhere to find it. This will be another long story to find a 5 volts regulator, which normally it's on any board. Any board has the 5 volts regulator, but not me. Oh. No. I can't. 1 second. Not me. Not me. I can't have 7805, which is the most common regulator. I have a home, but not here. So that's the most common regulator, yeah? 7805. 7, 8, 12. Can't believe I don't have a 5 volts regulator. That's why you need to have boards for spares. You have a lot, so you can choose what parts do you need. Easy. You know what? Let me try and find. Maybe I have one. I remember I bought a few, but I use them. I use them for same things. $5805. How hard can be? 5 volts regulator. That's all what I need. It's just a basic one. 5805. I need a board. I need something to get that chip out. Oh, maybe 1 second. 580. $5805. Yeah. So what do you think about this? Huh? So we have a 5805. Yeah. What I will do with this one? Let me check the pins to be sure. Yeah. 1 second. 5805. Image. Okay, let me switch. Yeah, that's 5805. Okay, the number 3 pin is output. Good. So we will have something like that. This is another dodgy job. So we have plus, yeah, minus, obviously. You can't see, sorry. The focus, where is the focus? Okay, plus, minus. So we have ground and output. So we have something like that. We have ground. We have output. Come on, I need another solder iron. Okay. And I need a wire. I need a wire to go to the other power supply, the 12 volts one. Yes, I will get this power from the 12 volts power supply, because obviously the main power rail is 36 volts or 34 volts, which is too much for this regulator. Yeah. So I think we are fine, you know. So what we have here, we identify a thing, we burn a thing, yeah, and we modify the, yeah. So we find the fault, we burn something, and we modify the schematic, yeah. So we cover a lot of aspects today, and we need 12 output of that diode, which is on this capacitor, which is here. This is a nice toy, I can't believe it. And each output is protected by a Zener diode. You see, this is a quality thing. Okay, so let's see now. Now is the moment. Cable plugged. Let's check the voltage. 5 volts on the output, you can see there, 5 volts, yeah. The other power supply, the 12 volts one, it's working fine, 12 volts. So we are fine. Yeah, one more time, what I did. I took everything out. I used this regulator, which this is the output. Here I got 5 volts. And I took the voltage from the output of this coil, which is 12 volts, yeah. And yeah, hopefully you can learn something from this. A simple job, just replacing a diode. That's all what I had to do, replacing a diode. But just because I start playing with the diodes, I burned that chip, and I have to modify and use another regulator, which is, this is a linear regulated 5 volts one, yeah. So now I'll put all back. We'll see if it's playing, if it's working. 1 second, I'll put the connectors. We have the speaker here. So we have few things to learn from this. The first, whatever happened, you have to carry on, you know. That's an important lesson. Things goes wrong, yes, many times, like now, yeah, but you have to keep on. And the fact we modify a basic power supply 5 volts from a switching to a linear one, there's nothing wrong with that, yeah. Probably it will take 1 pence more every month. So that's the only difference, yeah. The linear ones, they are less efficient compared with the switching ones. But the difference is so it's not important, you know. This is just a little bit. Just try to put this back. And here we have few connectors, you know, like speaker connectors. Yeah, it is back. Let's plug back the connectors. No, another screen. That's not. That's not a lost connection. No, that's the screen. Yeah, but I think it's around £50. Yeah. Probably tomorrow will be ready. You can check eBay and see. Yeah. Yeah, yeah. Okay, so everything is connected. Let's see. Let me plug the power. Power is plugged. Wow. It's on. We have lights and things. I'll show you after, yeah. Let me connect by Bluetooth with my phone. Bluetooth. Okay, I cannot see the Bluetooth device here. Probably it's different catch, but it's on. It's alive. Yeah, you can see the lights. And the Bluetooth light is flashing, yeah. Well, I'll try to find out what's going on. Should be some okay, so you have to keep press the pairing button, yeah. So now we have here connected, yeah. Let me find a song, non copyright song. Song, music. Okay. That's sick. The quality. Yeah, I have some customer here, but just wait the customer to go on and I'll put the volume up. But the thing, yeah, probably can't listen to the music. You can't hear the music. Just wait 1 second. 1 second. Okay, so we learn a few things. That's good. You know, every time when you learn something, that means you didn't waste the time. Thank you. One more time, that's the speaker.
Don't try this yourself. It's extremely dangerous.
That's sick. Okay. But nice sound, you know, the bass, the high frequency. Nice sound, nice sound. Nice toy, nice toy. Yeah. So anyway, thank you for watching. Yeah, so if you have this problem, you know now what to check. You know, you have the 12 volts power supply, which is always on. You have a 5 volts power supply, which is always on, and you have a 3.3 volts power supply, which is always on. Yeah, and after that you have a small transistor switch, which is it's switching only when you press the power button. It's sending voltage to the processor and the BIOS. Yeah. Okay. That's nice. You know, I should buy something like that, just to have it home to connect to the on the Bluetooth. It's nice sound. The sound. 2 bass and like 4 tweeters, like high frequency. That's nice. That's a nice toy. Sony. That's great. Okay, so this video is 2 hours long. You know, I can see on the OBS 2 hours. 2 hours. Yeah. 2 hours long. It's a lot. Yeah. The job is, look, this is the chip which I burned it, and I try to find it on Google, but it's nothing on Google about this chip. Yeah. 2 hours, but hopefully you understand how the things work. Yeah, how we diagnose the things, how we move over to find exactly what's going on there. Yeah. And yeah, and the job is done. You know, doesn't matter, we go wrong. You know, I burned the chip, but I replaced that power supply, yeah, with different one, and everything is fine now. I'm sure it will be fine. What do we have there? Like 300 milliamps, and that chip is supposed to supply 1 amp, the 5 volts one, so it's fine. It's not even getting hot, so everything will be fine. Yeah. And yeah, the thing can go wrong. You think I'm not burning things? Yeah, I do. Like now. And it's not even my fault. I just replaced the diode with a different one. Yeah, so we learn not all the diodes are the same. They are switching different. I know that. I knew that. But I was expecting, like, you know, what can go wrong? It's a switching diode. It's a Schottky diode. Should work. But looks like it's not. Okay. Don't forget, like and subscribe if you like the video, and see you later. Yeah, bye.